In this video, we would like to explore every type of rotation. Namely, there are 5 rotations here, and each rotation we're going to explore with the given graph. Okay, so as you can see, the formulas provide you every type of rotation in terms of the coordinates of the vertices of the shapes that you're trying to rotate. So here, the 90 degrees clockwise, we're going to play around with this one and the first graph. As you can see, the original xy coordinate will transform in such a way that the rotation transformation, the new image, the final image, the rotated image, will have coordinates y comma negative x. Okay, so we're going to use this formula to find the transformed, or rotated in this case, shape. And as you know, the rotated shape will not change the lengths of the sides or the area of this shape, right? It will just simply rotate it about the origin. Okay, so every single rotation that you see here is going to be rotation about the origin, either in the clockwise direction or in the counterclockwise direction. So in the first example, 90 degrees clockwise. So first we've got to find the original points A, B, and C, the vertices, the coordinates of these vertices, and then we're going to use the formula to find the transformed or rotated image. So the coordinates of A, and these are unit grids, okay, in units. So -1, -2, -3, -4, -5, -6. Okay, and the same thing up and down. So -6 and -6. That's the coordinate of A. The coordinate of B is -6 and 3. The coordinate of C is -2 and 3. Alright, so now we're going to use the formula. Now notice another way to check yourself is to understand that first we're going clockwise. So the B and C will be in the quadrant 1 and not in quadrant 2, right? Because we're going this way, right? We're basically moving into the first quadrant for these two vertices, C and B. And also one way to check yourself is that since we're talking about 90-degree transformation, and in this case rotation, the B and C should be perpendicular to B prime and C prime. All right, so that's another way to check yourself. So B and C and the B prime and C prime should theoretically make a 90-degree angle if you were to extend the B and C as a much longer line. All right, so that's another way to check yourself. So basically, since B and BC side is horizontal, parallel to the x-axis, the rotated image, B prime C prime side, should be vertical and parallel to the y-axis. All right, so let's check that. So as you can see, the formula says y comma negative x. So we're going to take the y and we're going to place instead of the x here. And then we have to negate the x, the original x, and place it into the y coordinate. So negating the -6 should give us +6. All right, so now let's check that. And notice that A prime, since the original A is in quadrant 3, the A prime, since we're going clockwise, should be in quadrant 2. And that makes sense because as you can see, -6, 6 is in quadrant 2. All right, so -6 is here, and then 6 will be all the way up there. Okay, so this is your A prime that you found. So now let's find the rest of these coordinates using the formula again. Right, so we're going to take the y, copy it, place it into the x, and then negate the x and place it into the y. So it's 3, 6. And notice it makes sense with what we talked about, that the B prime and C prime, as we're going to see, should be in quadrant 1. Because the original B and C were in quadrant 2, and we're moving clockwise. Okay, so 3, 6. Let's find that 3, 6. That's here. Okay, that's a B prime. And remember, we said that the B prime C prime side should be vertical, okay, and perpendicular theoretically to BC side. Right, so basically we have to have the same x value for the C prime. So is it really true? Yes, it is, because the y value was the same for the B and C, right? So these two move on to the x, as we know, based on the transformation. Right, so we take the y, we place it into the x, value there. And then we're going to negate the x and place it instead of the new y there, right? So 3 comma 2. Notice it's the same x value as we expected, and it will be the b prime and c prime side will definitely be vertical and parallel to the y-axis, and it will be theoretically perpendicular to the BC, right? So if we extended the line from BC, we would see that b prime and c prime would be perpendicular to that line, okay? So I'm just going to extend it using like this, so you can see that the b prime and c prime is theoretically perpendicular, okay? So if I were to connect it, you will see that it will look like something like this. Okay? So notice right away, this is indeed a 90-degree rotation in the clockwise direction. Okay? Because the BC were in quadrant 2, now the B prime, C prime are in quadrant 1, and that's what it should be. And the A was in quadrant 3, now the A prime is in quadrant 2. So we're moving clockwise. Okay? So this is done correctly. In the second example, we have a 90 degrees counterclockwise rotation. Counterclockwise is going to be a different direction rotation than it was in the first example. It means that theoretically the A prime should not be in quadrant 2. Because originally it's in quadrant 3, it cannot be in quadrant 2. It's instead, the A prime should be in quadrant 4, right? Because counterclockwise is moving this direction, right? So we're going like this. So here we went like this, right, about the origin. But here about the origin, we're going to rotate the other way, right, the counterclockwise. So A prime should not be in quadrant 2, it should be in quadrant 4. So if you take a look at this, you see that the formula is slightly different. You switch like you should for 90-degree rotations. You switch the x and y, but you negate it differently. This time you will negate the y and you will leave the x, all right? So here, let's find the original coordinates. So -3, -3. For A and -1, 0. Correct that a little bit. -1, 0. And C is 3, 0. And D is 5, -3. 5, -3. So now following this formula, we negate the y and leave the x alone. So negating the y gives us 3. Leaving the x alone is -3. Let's find that. So it's going to be right here. That's A prime. So we're negating the y, negating the 0 does not change it. We leave the x where it is. So 0, -1 is here. That's B prime. And 3, 0, so we negate the y. That stays, the 0 stays, and then leave the x as it is. 0, 3. So that's C prime. And then finally, negating the y, that's 3. And then leave the x, so 3, 5. So that would be right here. Okay, let's connect this now and see what we got. Okay, so that would be something like this. Okay, and also I need to mark this as a D prime. So as you can see, it does look like it's a 90-degree counterclockwise rotation, right? Because like we said, A prime should be in quadrant 4 and not quadrant 2, like in the first example. Okay, so this is indeed true. And notice that when it comes to 90 degrees, once again, the perpendicular relationship between A prime and D prime and AD is there, right? Because A prime, D prime is vertical, parallel to the y-axis. AD side is horizontal and parallel to the x-axis, right? So there is perpendicular relationship, all looks good. Same thing, B prime, C prime is perpendicular to BC. Right, so this is correct. Now the next one is an interesting case. It says 180 degrees clockwise or counterclockwise. Why is it going to be the same formula in both directions? Well, notice that if I kept on going, let's say in the second example, my A double prime would have been in quadrant 1 if I were to rotate one more time, 90 degrees counterclockwise. In the same manner, if I were to rotate, in this example, if I were to rotate clockwise 90 degrees, like in the first example, my A prime would not have been in quadrant 4, it would have been in quadrant 2. And then if I were to rotate one more time in the clockwise direction, my A double prime would have been in quadrant 1, and that would be exactly in the same place. Okay, so if I were to go counterclockwise, so counterclockwise or clockwise, 180 degrees does not change the formula and does not change the position. You will be in the same place. So you can go in either direction as long as it's 180 degrees. You will use the same formula. It will be exactly the same shape and exactly the same position. All right. So let's experiment with this by taking a look at this. So negative x, negative y, right? So let's find the original coordinates. Negative 3, 2, 1, 5, and then 0, 0. So the formula says not to switch. That's the good news. Okay, not to switch. It just says to negate both, right? Notice that in the 90-degree rotations, we switched the coordinates. We negated it differently, but we switched the coordinates, right? X and y. But here we don't switch. We just negate each x and y, right? So if we negate, that's easy. 3, negative 2. Negative 1, negative 5, right? Just negating each coordinate. Now 0, 0 is not negated. You wonder, why is it not negated? Remember that each rotation is about the origin. So when you do it about the origin, if a vertex of a figure is on the origin, the vertex of the final image or the rotated image will not change. It will be the same. That's why no matter what you do to the vertex 0, 0, it's not going to change anything. And that would be true in every type of rotation, 90 degrees clockwise, counterclockwise, right, to 70. We're going to take a look at that. That doesn't change. So if your vertex is at the origin, it's not going to change anything because you're rotating about this point. So imagine that this is the center of the circle. Okay? When you rotate your circle, your center is not going to change. Okay? So imagine that A and B were points on the circle. It's probably hard to see that geometrically, but imagine these were points somehow, and the C was a center. No matter how much you rotate or where you rotate, the C center would be the same. So that explains why the coordinate 0, 0 is not affected by either of those formulas here. Okay, so let's find these points. 3, negative 2, that's here, A prime. Negative 1, negative 5, that's here, B prime. And then 0, 0, that stays. So let's, I'm going to use the green color now to show you what we got. So we got something like this. Okay, and let me mark that this is a C double prime as well, not just the original C. Notice something really cool. You might wonder, is this also reflection? And I'm going to talk about reflection in my separate video, but notice this is indeed a reflection as well. It's a reflection about the origin, if you think about it. All right, it's a reflection about the origin, and it makes sense because the formula for the reflection about the origin is negative x comma negative y. So that's an easy piece to remember. It will help you differentiate this type of rotation from all other rotations. So reflections about the origin and the 180 degrees rotation in either direction, clockwise or counterclockwise, will be the same formula. Negative x comma negative y. Okay. So now let's talk about 270 degrees clockwise. This is an interesting case. Notice that 270 degrees clockwise is the same as the 90 degrees counterclockwise. You might think, why is that? Well, think about this. If we were to do 90 degrees clockwise once, imagine we did it 3 times. A prime would be the first time here, quadrant 2. The second rotation of 90 degrees clockwise, it would be in quadrant 1. And then A triple prime, the final rotation by 90 degrees clockwise one more time, would be in quadrant 4, just like it is here. So when you rotate 3 times by 90 degrees clockwise, essentially 270 degrees clockwise, you're doing the same thing that you were to do if you went 90 degrees counterclockwise, right? You're doing the same thing, except you have to do 3 rotations of 90 degrees clockwise, right, to make it 270, because 90 times 3 is 270. Right, so it's going to be the same formula. It makes sense that you're going to be winding up at the same exact place, same position. Right, so let's think about it. So whenever you're being told 270 degrees clockwise, think about it. Just think about the other direction and simply 90, right? 90 degrees counterclockwise. So let's find the points. So 1, negative 3, 3, 3. This is 6 and negative 3. So now we need to use the same formula as this one, right? Negating the y and leaving the x as it is. So 3, 1, negative 3, 3, and then 3, 6. Okay, so let's find that. 3, 1. 3, 1, then we have negative 3, 3, and then we have 3, 6. So that's C prime. Let's connect this guy now and see what it looks like. So we're going to get something like this. Okay. So notice now, let's check it. Does it look like it were it simply went by 90 degrees counterclockwise? Indeed it is, right? Because our B was in quadrant 1, and now the B prime is in quadrant 2, and that does look like it's going counterclockwise by 90 degrees. And indeed, A prime C prime is perpendicular to AC, because A prime C prime is parallel to the y-axis, AC is parallel to the x-axis, right? So horizontal versus vertical, there is definitely a perpendicular relationship, so definitely a rotation by 90 degrees counterclockwise. So as we can see, 270 degrees clockwise is the same essentially as 90 degrees counterclockwise, the same formula. In the same manner, 270 degrees counterclockwise is the same as 90 degrees clockwise. Right, so that's going to be the same. So these two, that's why the formulas match here for the first one and the fifth one. So let's experiment here. And then we're going to confirm it's going to be really true. So let's see. So A is negative 5, negative 2. Correct this. Negative 5, negative 2. B is negative 4, 5. C is 2, 5, and then D is 2, 0. So now we're gonna either this one or that one, same formula. So we're gonna copy the y, we're gonna negate the x. So copying the y, negating the x, copying the y, negating the x, copying the y, negating the x, and then copying the y, negating the x. Okay, so let's see. Negative 5, negative 2, same, negative 2, 5, sorry, negative 2, 5, that's it. 5, 4, that's here, B prime. 5, negative 2, that's here, that's C prime. And then 0, negative 2, so that's D prime. So let's connect this guy. And let's see what happens when we connect him. So it looks something like this. Now check this out. Let's confirm that it is definitely like a simple 90 degrees clockwise rotation. The same thing as 270 counterclockwise. So notice that Clockwise means what? Means that the A prime should theoretically be not in quadrant 3 anymore, but quadrant 2. Indeed it is. Indeed it is, right? It's in quadrant 2. Same thing for the others as well, okay? So now notice there's perpendicular relationship because B prime C prime is vertical and BC, the original side, was horizontal, right? So there is perpendicular relationship, so that this is indeed just like 90 degrees clockwise rotation, all right? So I hope this was useful and fun. This was a long video, but you probably got a great idea of what this is. And I'll see you in the next video, and thank you for watching.